Alright, so I've already shown you a lot of basic stuff that you can do with strings, numbers, and booleans, but now it's time to see the applications for these things. One important application of booleans is known as control flow, which I might have said in a previous episode as flow control, but apparently they are different things. Go figure. Now, a lot of people have described programs as being recipes that the computer follows line by line to figure out what it is that it has to do. Now, computers are not, they are significantly more advanced than that recipe on the side of your macaroni and cheese box, so they can perform more complex operations. So I'm going to show kind of an example here. So let's start by declaring a variable. Alright, so let user age equal 18. So let's say, for example, this is for a website where it has to validate a user's age before they can make their account. So we don't want everyone to be able to make their account, so we want them to be, let's say, older than 18 years of age. I don't know what kind of website this is, but so we're going to use what is known as an if statement. So it looks like this. If, open parenthesis, and then some condition. Wrong way. And then two curly brackets. This looks kind of similar to a function, but it isn't. So we're using this if user age is greater than or equal to 18 here. So let's see what this does here. Probably will take several minutes for the logs to show up. Okay, it's 3:21. Of course, it didn't load yet. And there we go. So this ran. So, but what if I were to choose a smaller number, like 1? Oh, you know what? It would probably make more sense if I put this here. So you can see. So as you can see, it printed done. However, it didn't even go into this if block here. So whenever it's checking and the computer is checking the if statement, it goes here, it says if. Okay, it's asking me something. Does this condition evaluate to true? Anything in between these two parentheses. If it does evaluate to true, run everything in between these two curly brackets. If it evaluates to false, then just go down here and move on with the rest of the program. So let's go back here. Let's say that someone is 9999 years old. I hope I said enough nines. Then this will still run. I don't know what I expected. Maybe this time it'll load right. Yep, greater than or equal to 18. So as long as it's greater than or equal to 18, it will go here. But what if it isn't? So what if we want to we could very well do this. So we could do something like this, but it is rather verbose, and we don't want to do that. Instead, we use what is known as the else statement. So now, let's run this with someone who's rather young, shall we say. Rather young person this is. Not old enough, done. So what this will do is, as it checks this, so if is user age greater than or equal to 18, no, then you jump to the next else statement. So then this else statement runs, and it only runs if the if statement doesn't. So I don't know why I'm doing all these 9s for people's ages. Suppose it's a nice character, nice number. Greater than or equal to 18 runs, as does done, but not this one here. Now, what if we wanted to make sure that they were, I don't know, a positive age, because we don't want time travelers using our program. So that we could add another check here. So let's say if user age is less than 0. Sol.log no time travelers allowed. I don't know why anyone would have a negative age, but this is the best reason I can come up with. No time travelers allowed, but it also displays this not old enough. So, in case you couldn't guess, there is also another keyword you can use to shorten this up by using, else if user age is less than 0, curly bracket, oops, wrong one. And I'm just going to cut this out here, because it's easier than typing it again. Now let's make sure this works. I don't know what went wrong. Why is it not doing that? Because it should be printing something. Yeah, there we go. No time travelers allowed. Done. So what it's doing here is, okay, go to the first if statement. Is this condition true? No. Jump to this next one. So this is else if. Is this condition true? Yes. Go here. Then it goes back to the bottom here to line 11 and continues on its merry way. So that is if, else if, and else. And do note that you can actually do an infinite number of else ifs. Okay, else here, boom. Let's do user age. I'm typing everything wrong here. So I forgot to mention this in the Boolean operators video, but you can also use 2 equals signs to mean equality. So if user age is equal to, let's say, 1, console.log you are 1 year old. So greater than or equal to, less than 0. So you can do as many else if statements as you want. However, be aware that they run in order, which I will show an example of in a minute here. You are 1 year old. Now, let's show another. So, if we were to put, say, for example, so if we were to do a statement like this, if user age is greater than or equal to 18, else if user age equals 18, this else if statement will never run, because any condition where this would activate is already captured by this one here. So that's It might come up occasionally, but that's just something to look out for. Now this video is already getting rather long, so I will only go into one of the other two control statements that I can think of here, and that is the, not for loop, sorry, the while loop. So, let I equal to 10, and while I is, let's see, greater than or equal to 1. Did I set that up right? Alright. And lastly, so a while loop, it's called a while loop because it's just going to keep looping over itself until this statement here is false. So in this case, I starts at 10. Is 10 greater than or equal to 1? Yes. Console.log 10, I is equal to 10 minus 1, which is 9, and then it goes back through. So I'm going to run this to show you. It may take a minute. I'm without a doubt. There we go. That totally did not take a tenth of a second. No, 20th of a second. Alright, so as you can see here, you are 1 year old. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, done. So, that's, yeah, so quick thing you can do here, I equals I minus 1. You can just write it as I minus minus, which, yeah, I don't know why we needed that, but it's there. So one thing to be wary of is if you forget this I minus minus here, this creates what is known as an infinite loop, since this condition will evaluate to true forever. You do not want to do this. I'm not even sure that it will allow me to run it. If I do try to run it, it might crash things, so let's see what happens. So it is currently running, so it's, let's see, does it start showing up here? It might. So it's just something to be wary of, is you always want to make sure that this condition can become false somewhere in this loop. So it's currently running. Let's take it, it's been going on for 10 seconds now. It's actually, yep, something bad's happening. Not a good idea to have an infinite loop. So it's the kind of thing that may occasionally happen to you if you aren't careful, but, I mean, it happens to the best of us, getting these infinite loops, that is. Yep, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, all the way down. It's going to go down forever. So we don't want that, so I'm just going to click cancel. I hope it stops. Okay, it did stop, good. Does it count as failed? I think it might. But yeah, just infinite loops may happen, so if your script seems to be taking an unusually long time to run, then that's probably why. So don't forget to include that there to change it. Now, in fact, this kind of while loop statement here is so commonly used that we have a borderline unreadable syntax for doing it in an easier way. So it is what is known as a for loop. That's F-O-R. You start with an assignment statement. I'm using J instead of I this time. Then you have a semicolon. But that's not the end of the line. You go J is greater than or equal to 10. And then semicolon again, space, J minus minus, close parentheses there, and curly brackets, console.log J. So this here is extremely compact in exchange for being borderline unreadable and difficult to understand. Heck, I don't even know why they chose the word for here, but go figure. Now this is exactly the same as this statement here, just in a more compact form, which we should see here. Yes, good. Yeah, it might take a minute to load. I hope I didn't set up an infinite loop in this one. I don't think I did. Oh wait, J is Oops, I did, didn't I? Whoops. No, it's still running. Oh wait, no, this one's not gonna run at all, never mind. Okay, so J starts at 10, stop once J is greater than or equal to... Oh no, I see what I did wrong here. Wait a second. I always forget how these for loops work. Just give me... Alright, there we go. We did get it right. So, the way this for loop kind of works is you have this first statement here, which is run, this let j equal 10, which runs before it starts running over the loop, which is known as iterating. You have this condition, which is checked after every loop. So it checks to see, is j greater than or equal to 1? If so, repeat the loop. If not, then break out of it. And this j minus minus is run at the end of every loop iteration. And this is run during each of them. So I ran it and got this output here. You are 1-year-old, I is 10, I is 9, I is 8, I is 7, etc. And j is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, done. So this is just a more compact way of doing a while loop. I have not used while loops in some time. In general, you're going to want to use while loops whenever you don't really have any way of knowing when something is going to end, whereas a for loop is usually better if you know exactly how many times you're going to want to do something, such as iterating over a list of items, which I'm going to be getting to in a later video. So this video has been rather long, but control flow is really important, especially if you want to make video games or something like that, where you want all these different conditions and such. But yeah, so I hope this has been informative, if not a bit long, so that is all for this video.